Okay, so this is a quick explanation of the principle of operation of phototransistor in a dark activated circuit. So we have our phototransistor here, voltage regulator here, 9-volt power supply here. That's a 100k resistor, and because the output current is quite low, we're running it through a NPN transistor. So we got our photoresistor there and our NPN transistor. So let's do a little demo. So as you can see, we're in light, and when I activate it or darken it, the LED comes on. So the principle is just basically a voltage divider. So we've got our 100k there, there's our phototransistor, there's our output, there's our normal transistor, and there's our LED. So pretty much the phototransistor behaves like a resistor. In ambient light, it has a low resistance, so R2 in this equation is quite small, so therefore the output voltage is quite low. When it gets dark, the resistance R2 of the phototransistor gets much greater. Now it's a bit, what is it? It's around, it can be 80k, it can be 300k. It's much larger, so it's a bit of a movable feast. These are just typical values I've got when I've done readings. But bottom line is, when it gets dark, the resistance of that gets very, very high, and therefore your R2 is higher up here, so therefore you get a better voltage output. So now you're getting greater than 2 volts as opposed to almost 0 volts. Now the current from this voltage output is pretty low. It's only about 50 microamps because of our high resistance here. So we've got to use the normal transistor here just to beef up our current to actually light the LED. So when you use the transistor here, it gives me about 2.8 milliamps. So just again, as you can see, you cover it, it comes on. Now, is shadow enough? It can be, okay? But can we increase the sensitivity of the circuit? Well, we'll see. Okay, if we change the R1 resistor to 50k, we will get a greater voltage output for a lower R2, if you like, a lower darkness value of R2. So let's see how that works. So I've replaced it with 51k, and you might see there's a slight glow on the LED, so it's already been activated. And actually, if I just bring it into shadow, it does activate it. And obviously then complete darkness and it's lit. So yes, we can change the sensitivity of the circuit by playing around with, and you can see it's kind of just shadow there as opposed to being dark, playing around with the resistor values. So that's it, done. Bye.